In this video, you will see a concept presentation of the new variable speed genset technology. Mahindra & Mahindra, in association with Sidimac Mechatronics Private Limited, presents variable speed genset technology. The Mahindra & Mahindra Sidimac variable speed genset is an innovation that has been specially created for gensets operating at telecom tower sites. The fuel consumption savings are exciting, up to 20%. This technology is now available for new DGs factory fitted as well as for existing gensets as a retrofit kit. It has been successfully installed at many telecom sites across India and is penetrating the market day by day. You may be thinking, how does this new technology work? And how does it bring fuel savings? Let's have a look. In our present telecom DG setup, the DG generates about 230 volts AC at 50 cycles. And no matter what the load, the engine always runs at a fixed speed of about 1500 RPM. The fixed speed is rated for full load conditions, but it is not the optimum speed when the load on the DG is low. As a result, the fixed speed running results in poor fuel efficiency in part load conditions. At telecom sites all over India, the DG operates in part load conditions for most of the time. Thus, the DG operates at poor efficiency most of the times, resulting in higher fuel consumption than what is actually required. Due to this low fuel efficiency, the site operating costs for the telecom industry goes up. In summary, we can say that the fixed speed DG running at telecom sites results in a significant burden to the telecom industry due to high fuel expenses. To resolve this issue, the new technology is designed to avoid fixed speed operation by making use of variable speed operation. The new technology brings attractive fuel savings. Let's find out how. A variable speed genset is a load-sensitive DG that changes its speed depending on the load condition. At full load condition, it runs at the rated 1500 RPM. When the load on the DG reduces, it runs at optimum speed which are lower than 1500 RPM, thus improving the part load fuel efficiency of the engine. The operating speed ranges from 1000 to 1500 RPM. Due to this load-sensitive variation in speed, we achieve lower fuel consumption in part load conditions, bringing in good direct savings. In addition, the wear and tear of the engine reduces and its life increases. Now, let's see how this new technology works and what its main elements are. Variable speed genset contains a special electronic kit which is designed to enable variable speed operation of the DG. This kit is composed of two main components: an intelligent I-18 actuator and a special control panel. The I-18 actuator replaces the stop solenoid of the engine. The actuator is connected to the FIP stop lever to regulate the fuel flow into the engine and thereby have a control over the engine speed. When the genset is in operation, the control panel continuously senses the DG load and sends the load signal to the I-18 actuator. Based on this load information, the intelligent I-18 actuator continuously calculates the optimum engine speed suitable for the measured load. Accordingly, it controls the FIP lever to achieve the optimum engine speed. As a result, the genset speed varies based on the load, and the fuel is saved. Now, let's take a look at the important characteristics of the new variable speed genset technology. And let's look at the features one by one. Compatibility with new and existing gensets. The first important feature is that this variable speed technology is available for new gensets as well as existing gensets in the field. For existing gensets in the field, this technology is available as a special retrofit kit. The retrofit kit is compact in size and can be easily carried on a two-wheeler to the tower site and is offered by Mahindra & Mahindra to telecom tower companies. The retrofit process takes only about 4 hours to finish on site. And importantly, it does not require any modification to the telecom shelter equipment such as PRU, PMU or SMPS. As a result, within half a day, a fixed-speed telecom genset can be transformed into a variable-speed, fuel-efficient, fuel-saving telecom genset at the site itself. Compatibility with all types of engines and alternators. In a fixed-speed genset, the output voltage is 230 volt at 50 Hz. That's not the case with a variable-speed genset. The variable speed genset runs at 1500 RPM and develops 230 volts AC at 50 Hz only in full load condition. In low load condition, the variable speed genset smartly reduces its speed to as low as 1000 RPM. The genset output can be as low as 140 volt at 33 Hz. The variable speed technology is compatible with all types of alternators: Crompton Greaves, Stamford, Leori, Somers, etc. It also works with all types of AVRs and all Mahindra Powerol engines such as 10, 15, 20, 25 and 40 kVA rating, both single-phase and three-phase. However, note an important detail. The retrofit kit part numbers are different for different genset ratings. Compatibility with telecom tower equipment. The variable speed technology is compatible with all types and makes of PRU, PMUs, be it Pace Power, Acme, Synergy, Intelex, Delta, and also with all major makes of SMPS, be it Delta, Emerson or Eltec. The only difference as far as the PRU, PMU connections are concerned is that in case of the variable speed genset, the genset alternator's power flows into the new control panel and from there it flows towards the PRU, PMU. In case of old control panels, the PRU PMU sometimes receives electrical power straight from the genset alternators. One important point to remember is that the BTS battery charging speed and efficiency does not change due to the variable speed operation. The variable speed technology supports remote start-stop as well as fully manual mode. Engine safety assurance. The variable speed retrofit kit support all engine safety features, and just like the old MCB panel, the new panel also receives LLOP, HWT, LFL, RWT sensor and switch inputs. In addition, Mahindra & Mahindra has tested in-field conditions and validated that all Powerol engines develop sufficient lube oil pressure in the entire variable speed operating range from 1000 to 1500 RPM and also have excellent engine cooling capabilities. As a result, the variable speed range of 1000 to 1500 rpm is certified to be safe for the engine's operation. In summary, the new engine control panel always ensures that the engine does not experience dangerously low lube oil pressure or dangerously high cooling water temperature. If you want to know the load on a variable speed genset, you need to measure both the DG output current and the DG output voltage. You need to multiply them to get the DG load in VA, watt. Do not calculate the DG load using DG current alone, like you do in case of a fixed speed genset, because that method can give you wrong results. Special features of the new variable speed genset. As we have just seen, the new variable speed genset develops variable output voltage from 140 to 230 volt at variable frequencies from 33 to 50 Hz. However, such variable speed operation can sometimes generate under voltage or under frequency alarms in the PIU's control card. As a result, the PIU can send an unwanted remote stop command to the genset whenever it operates in the variable speed mode. To overcome this situation, the new control panel contains a special DC to AC inverter. This inverter is powered by the genset's 12-volt battery, and it develops 230 volts AC at 50 Hz frequency. To avoid the undervoltage or frequency fault alarm in the PIU's control card, the inverter's signal output can be connected to the sensing terminals of the PIU's control card. As a result, the PIU's control card will always sense 230 volts AC at 50 Hz, even when it may be running at the variable speed mode. As a result, the PIU control card will not develop an undervoltage or underfrequency fault alarm due to the variable speed operation. Importantly note that the inverter output is generated only when the DG is running. When the genset is off, the inverter output is turned off automatically. Before this presentation ends, let's take a look at the elements of the retrofit kit. Item number 1. New I-18 actuator and FIP linkage for engine start, stop and variable speed operation. Item 2. Mounting bracket for the new I-18 actuator. Item 3. New control panel with inverter inside. Item number 4. Mounting stand for the new control panel. Item 5. New engine wiring harness with connections for all engine sensors and switches. Item number 6. New power cable to connect the DG alternator's output to the new control panel.